Hello students. Today, we will discuss a problem about diffraction grating. The question sounds like this. When yellow sodium light with a wavelength of 589 nanometer falls on a diffraction grating, its first order maximum on a screen which is 72 cm away falls 3.32 cm from the central maximum. Meanwhile, a second source produces a line of 3.71 cm from the central maximum. First, determine the wavelength of the second source, and second, determine the number of grooves per centimeter on the diffraction grating.
Assalamualaikum warahmatullahi wabarakatuh. Now I'm going to show you how I solve this question. The question is, when yellow sodium light lambda equal to 589 nanometer falls on a diffraction grating, its first order maximum on a screen 72 cm away falls 3.32 cm from the central maximum. Meanwhile, a second source produces a line 3.71 cm from the central maximum. Before we start to answer the question, we need to extract the information from the question. Firstly, the question said lambda is equal to 589 nanometer. Then, it is first order maximum, so the value of m is equal to 1. Besides, the screen is 72 cm away. It means the value of L is equal to 72 cm. Lastly, it falls 3.32 cm from the central maximum from the first source and 3.71 from the central maximum from the second source. So, these are the values of Y1 and Y2. After we list down all the information, we can start answer the question.
Assalamualaikum warahmatullahi wabarakatuh, and hi, my name is Hati nama Faizal, and my entry number is 2066. So for my part, I'm doing question A, which is I'm doing the suitable equation for the question given, the wavelength of the second source. So the hint has already been given, which is the diffraction grating. Diffraction grating, we know and love that this is a single slit experiment, and not to be confused with double slit experiment that I'll show you about. So looking into this is the DSC, double slit experiment. So yeah, DSC. The equation is d sine theta equals to m lambda. So we know that d is the distance between two slits, S1 to S2 for short. M can be derived into two types, singular m and m plus half. Singular m is constructive interference, where it's going to fall on the bright fringes or the maximum fringes, and m plus half is destructive interference, where it's going to fall on dark fringes. And the order of m can be from 0 to infinity. It's all based on the fringe, the dark and bright fringe that appear on the screen. So yeah, that is a brief explanation for DSC, that was the experiment. So looking into diffraction grating, you have two types of equation, which is A sine theta equals to order to lambda, and D sine theta also order to lambda. The thing is, A is size of slit, for short, and D is not distance between two slits, but it is grooves, especially 1 over group. So yeah, we can see from the diagram, there's a slit. The size of slit will be similar, where we're not focusing on the distance, and this is the grooves, the lines. This is all the grooves, and this is the Y, the fringes, the central maximum. Yeah. So looking at the diagram again, you see this is the size of slit, this is grooves, and this is the fringes, the central maxima, the first order maxima, and the first order maxima, but on the bottom side, where m goes -1, but still you find the same answer. So yeah, the order can be from ±1 to infinity. So it depends on the fringes that appear on the screen. And yeah, that's the brief explanation, I guess. And let's move on to the question. Now looking at the question, already stated that it is diffraction grating, so this is going to be a sine theta equals to m lambda. We have all the values. We have first source values, the y and the l. The y is the bright fringe to the center maximum, and the l we have 70 cm from the screen, and the wavelength was the first source. We're trying to find the wavelength of the second source. We don't know what's the lambda value of L2. The thing is, to find the lambda of second source, we need to find dA. We don't have dA, so we're using the first source to find the value of the size of slit. So we know that sine theta is approximately tangent theta, which is all equivalent to y over L. The reason why, because when we total up the value, approximately almost the same angle, but yeah, something like that. We're using the formula that we learned in chapter 36, the small angle, where approximately will be the same value. So, including this into the equation, will become A times y over L equals to order of lambda. So we know that A, size of slit, is equivalent to length from the screen times the first order times the wavelength of the yellow sodium light. First source divided by the bright fringe from the central maximum. So this is how we find A. To find the second source of wavelength, we take the value of A, we times it with its y value, L, and we find the wavelength. We know that M is first order because this portion stated that first order is maximum. So following will be the same thing. So yeah, that's how we find the second source wavelength. I think that'll be all for my part. The calculation will be done by another friend of mine. And yeah, thank you. See you next time. Bye bye.
Assalamualaikum warahmatullahi ta'ala wabarakatuh. My name is Ahmad Adli bin Ahmad Zalfikar Hafiz, and I'm here to continue what Adib have explained. Let's go. Okay, so to answer the first question, we need to use this formula to get the value of A. Okay, so we enter the value of M, the value of the lambda, the value of L, and the value of Y1. Okay, so the value of M is equals to 1, and the wavelength of the first source is equal to 589 times 10 power of negative 9 meter times the value of L, which is 0.72 meter, divided by the value of Y1, which is 0.0332 meter. Okay, so when we calculate this, we get the answer for the value of A equals to 1.28 times 10 power of negative 5 meter. Okay, so after we get the value of A, we can surely get the wavelength of the second source by using the same formula, but we derive it differently. Okay, so the formula is wavelength of the second source equals to A times Y2 divided by M times L. Okay, so the A value is equals to 1.28 times 10 power negative 5 meter times Y2, which is 0.0371 meter divided by M equals to 1, and the L is still the same. We still take this one equals to 0.72 meter. When we calculate this using our calculator, we get the answer 6.58 times 10 power of negative 7 meter. And if you want to change it to nanometer, we get the answer is 658 nanometer. Okay, thank you. That's all from me. Ciao.
Hey, Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Akmal, and now I would like to talk about question B. So what question B wants? So it wants the number of grooves per centimeter on the diffraction grating. So if you remember, the formula d sin theta equals to m lambda, and then the sin theta in diffraction grating is equivalent to tan theta. So the tan theta equals to y per L, whereas y is the first order maximum from the central maximum, and the L is the distance from D to the screen. So from the equation, we can replace sin theta with the tan theta, and then in the tan theta, we can replace it with the y per L. So with the derivation of the equation, we can find the answer of D. So D equals to m lambda L per y. So what is m? M equals to 1 because it is the first order, right? Then lambda, what is lambda? Lambda we get it from the question, which is 589 times 10 power of negative 9. So what is L? L is given in the question, which is 0.72 meter. And then last but not least, y equals to 0.0332, which is given in the question. And then we can find the answer using the derived equation, which is we can get D is 1.28 times 10 power of negative 3 cm. So from the D, how can we get the groove per centimeter? The groove per centimeter is actually equals to the inverse of D. So we can insert the answer and then inverse it. So we get 782.87 groove per centimeter. So that's it. It's easy, right? So don't be panic when you get question. Then you just have to remember what have we learned in physics. That's it. Don't be panic. Okay? Good. So I think that's all from us. Please stay at home and stay happy. Okay? Okay, bye bye. Assalamualaikum.